All right, here we go. Decided to go ahead and send you guys a second video today. Your lucky day. I'm going to start with sensation. Going to start with um, the vision process, and I'm not going to take a whole lot of time here. Just kind of introduce that. I think some of this stuff I want you guys to review on your own. I'd rather do some of the more big picture stuff, with these videos than bore you with the entire vision process. So the guy on the AP Psych review, I mean, he went through all the parts of the eye and stuff like that. Cornea is kind of the windshield, the protective part of the eye. He called that, the iris, the colored portion. Muscle contracts to kind of allow light in. Pupil, that's where the light is going in to your eye. The lens, clear and flexible. It stretches, it relaxes. And as it stretches or it relaxes, as it's, contracting and releasing, it is kind of bending what you see, bending light, bending shape. The fovea is the center of the retina, and that is what allows you to have very detailed vision. Rods and cones, both those are going to be all over the retina. So your rods and cones all across the retina. It's not like you just have one rod or one cone. So as rods are all over the retina, that's what allows you to see in different degrees of illumination, right? That's what allows you to still have vision, night vision, for example, vision in dim light. And that's also, rods are also, so not only vision in dim light, but also allowing you to see things in motion, right? So not just seeing the TV as it sits there, but also cars driving by, or being able to see a volleyball coming at you, or baseball, that you're chasing down. Cones are going to be more directly attached to color, what allows us to differentiate between color, to see different colors at the same time. The trichromatic theory of color. Okay, so here we go. Trichromatic theory of color. Basically, there are three colors, right? And they respond to different wavelengths of radiation, radioactive, basically radioactive color wavelengths. And so you're going to have short waves, which is blue. So blue, the color blue in short waves. Medium waves, which is green. And then your long waves are going to be red, right? So the trichromatic theory, blue, green, and red. Blue is short, green is medium wavelength, and red would be long, right? Yellow is, okay, so yellow, that comes down to perception, right? So here's these senses, here's this light coming into the eye, and our brain has to make sense of it. Our brain has to perceive, these sensations. So yellow is our perception from basically our eye, according to this theory, our eye processing, both red and green waves, okay? So the eyeball doesn't know yellow is a color, for example, according to this theory. The eyeball is seeing red and green cones, and the cones are making sense of this. The cones are allowing light in, and we are perceiving the color yellow. The advantage is this theory works for the eyes, the anatomical structure of eyes, and it's all based on cones, right? So we know cones allow us to see colors. So the trichromatic theory of color, the advantage is it makes sense to eyes, right? That yes, we have cones, and here's three colors, and off of that, our brain just perceives these other colors. The other one is the opponent process theory. So this is going to take colors, and it's basically A and B are going to go together, and they're opposites, right? And you can't really ever see those together at once, black and white, right? Something's either black or white, not black or white. Now, the problem with this is obviously going to be, you guys like gray areas, right? So yes, there's black, yes, there's white, but there's also gray, which would be a combination. The theory doesn't directly address that, at least what you need to know for AP Psych. So when certain neural circuits are excited, they cannot process certain colors because those processes are inhibited. They're blocked, right? Because they can't process those opponent colors at the same time. So if I am seeing black, I can't also at the same time perceive that I'm seeing white, right? Does that make sense? So when blue is active, you cannot simultaneously see yellow, right? So as I am neurally processing blue, I cannot at the same time neurally process yellow. you can see opposites next to each other, but not at the exact same spot, right? So a red car and a yellow car might be going by, right? But they're in two different spots. They're not in the exact same spot. So I can make a distinction between those two opposite colors, right? A black car going by, a white car going by, but I can't see in the exact same spot. I can't see black and white. So the opponents here are blue and yellow, red and green, black and white. So there is no such thing, according to this theory, there is no such thing as you seeing a greenish red object or a reddish green object. You can't perceive it. Your mind, your brain cannot process that, right? So there is no such thing as blackish white, right? Whitish black. There, it doesn't exist. And the advantage here is it works for the brain. You know, it puts all the onus, all the responsibility on what we're able to perceive. We know we can't truly multitask. We can't pay full attention to multiple things at once. So this kind of works for that. The only other thing I want for this video is retinal disparity. So what you have two eyeballs. Newsflash, right? You have two eyes. They see two different things, right? So each eyeball, and I don't know if any of you guys have glasses that have different degrees of lens or not, where you might have, you know, perfect vision in one eye, but not so perfect in the other. So retinal disparity is, your eyeballs don't see exactly the same together, right? We basically, our brain kind of fills in. We are looking at an object with each eye, and our brain makes sense of that. Our brain perceives what we are seeing. So the definition I wrote down from the video, each eye has its own perception. And basically what we see, what we are perceiving is images overlapping in the center. The brain connects these together to produce one image. I'm sure you guys, right, have all done the test where, you know, here's something in front of you, close one eye and you see it from an angle, close the other eye and it shifts, it moves, and you see it from a different angle. Well, your brain is just overlapping that and making sense, producing one image. This is retinal disparity. Your brain being able to do that. That's important for depth perception. That is basically the amount of difference between each eye's perception. Some of us have really good depth perception, some of us don't, and that's just going to be the disparity, the difference between each eye. So you know, if one is a lot weaker than the other, your depth perception is probably going to suffer. Diplopia, that is double image. So basically, and this is on the brain, not on your eye. It's your brain's perception. So basically, when your brain is not able to take those overlapping images and shift it into one image, when your brain's not able to do that, you have double vision, right? You see two of those images, and maybe they're kind of looking like they're overlapping, but you see two rather than one. And your brain's just not producing a single image. So I do want you guys to go back and review the notes that we had from Unit 4 on vision. On that slide, you know, from that lecture slide, they were in order. So, you know, like we talk about light hitting the cornea, the protective windshield, light hitting that or whatever you're looking at and going all the way into the optic nerve, right? The very back of the eye, which the optic nerve sending that neural activity, the neural stimulation to the brain, and boom, you know, there's vision. So I do want you guys to go back and review that. And I'm going to stop the video here. Again, I just want to be kind of real short. And then the next video will be more on perception and, you know, a lot more detail than this last one. But we still have hearing and we still have touch and we still have smell coming in as well. So, all right. See you guys.